I picked it up. Okay, we've got a lot to cover, so we're going to kind of get started and go for it. My name's Graydon Blair, and I'm from Utah Biodiesel Supply. And for those of you who have bought my stuff, thank you. If you haven't, I sell stuff on how to make biodiesel and teach biodiesel courses and seminars and such. So I got started. Awesome, cool. We're going to talk about quite a few things today. First of all, what I have in front of me, I wanted to kind of just show you what biodiesel looks like, and then we're going to actually make a batch. We're going to titrate, and then we'll talk a little bit about some of the things with it. Hopefully you've got your copy. This has the recipe for making a really small mini batch. The title of this is Mini Batches of Biodiesel, and I want to talk a little bit about why it might be important to make mini batches, but first I want to explain some real basic chemistry of what we're doing. Okay, we're going to take an oil and see if that one works. Let's see if this one works. Hey, that one works. We're going to take an oil, we're adding methanol, we're adding a catalyst, and out of that we're going to get biodiesel, we're going to get some glycerin, and to a small extent we're going to get a little bit of water. Okay? How biodiesel is made is by taking oils that are squished out of seeds. Usually these are soybean seeds. I'll pass these around so you can take a look at these. And you get oil crushed out of it. And oil is called a triglyceride. Triglyceride are 3 fatty acid chains hooked onto a glycerin backbone. So this is glycerin. And these are fatty acids. Okay, we're going to come in here, we're going to add a catalyst. That catalyst is going to act like a scissor to cut these fingers off of your glycerin backbone, right here, here, and here, and attach them to methanol. So in the end, what we're going to have is a glycerin backbone that falls to the bottom. Notice there's a glycerin in the bottom of this. Then we're going to have a combination of a fatty acid and a methanol molecule together. We're going to get 3 of those. So out of 1 triglyceride or 1 oil molecule, you can get 3 biodiesel molecules, fatty acid, methanol, fatty acid methyl ester, which is a technical name for biodiesel. And then you'll have glycerin. What happens when you react that is the biodiesel rises to the top, and the glycerin settles to the bottom, and that's how we make biodiesel. So we're actually going to make a batch here. This is the real basic chemistry of how this works. If you'd like, I've got a whole article on the website devoted to the actual chemistry, and I walk through everything, how we make it. But this is just a general overview of what we'll be doing. How many of you have made a batch of biodiesel before? Oh, gee, this is going to be pretty good. So how many of you have titrated before? Cool. All right. Well, let's get to it. Why is it important to titrate?
Find free fatty acids.
Find free fatty acids. We've got to identify how many of these buggers have broken off of that glycerin backbone. So they're floating in the oil. Okay? When we make biodiesel, I'm going to flip this up and do a little bit more chemistry here. Oil in nature, sometimes these fatty acid chains break off. We call those free fatty acids. If you try and take a free fatty acid and mix it with catalyst, what do you get? Soap. Instead of getting biodiesel. When we do this, it likes to rob the catalyst that we're using to make biodiesel. And so when we titrate, we're simply seeing how many of these fatty acids have broken off and are free and floating in the oil, so that we can add enough of our catalyst to fully neutralize them into soap and still have enough left to come in here and still make fatty acid methyl esters or biodiesel. So we're actually going to do a titration, and then we're going to make a little batch of biodiesel. One of the things that I wanted to focus on today was mini batches. How many of you have made a batch of glop? How many of you screwed up a batch of biodiesel? Better question. You got a few in the room. If you haven't yet, you will soon. So. It's a lot easier to make a batch of glop in a pop bottle than to screw up a 500-gallon batch. And so we're going to be showing you how to make liter batches today. I can't stress enough how important it is to really get to understand how to make liter batches and make them out of your feedstock. If you have some feedstock or feedstock meaning oil that you don't know how good it is, make a batch out of it on a mini batch. Let it settle and then test that. That'll let you know what you need to do to adjust to make a big batch of biodiesel. So with that, we'll get started here. I'm gonna let that cool down a bit. We'll do some titrations. Okay. On your sheet, on the second page, is all about titrations. If later on you want more details, you can actually refer to our website. We're at utahbio.com. I've got a whole series of tutorials on how to do this. But first of all, we're going to start off with some oil. This oil I've never titrated. Someone just gave it to me. So I have no idea how it's going to react to make biodiesel. I'm going to take 10 milliliters of this oil. I'm going to use some isopropyl alcohol. And then I'm going to use titration solution to titrate with. I'm using potassium hydroxide to make this batch of biodiesel today. And so to make my titration solution, I've taken 1 gram of potassium hydroxide, and I've added it to a liter of water. And I shook it up and had this ready. When you make titration solution,
Are there extra sheets for people who just left in?
Yeah.
there are, way over there, yep.
Okay.
If you don't have one, come and grab one. When you make titration solution, you need to write on it the date that you make it, because it's only good for about 90 days. If it goes any further than that, it's going to start getting weak. That's because the moment you open potassium hydroxide to air or sodium hydroxide to air, it begins losing efficacy. It carbonates with the air. And so your titrations can actually start increasing as this goes bad, which would stink because then you'd make a lot of soap. So you get good reactions, but you're adding way too much catalyst. Okay, so I've mixed this up. I'm going to take 10 milliliters of isopropyl alcohol. Okay. And I'm going to add 1 milliliter of oil. I've got this pre-measured. A tip, if you do a lot of titrations, I like to put a bubble at the top of this thing because it's a lot easier to read your syringe with a bubble than it is with the syringe top. I'll put it in there. And then I'm going to use a magnetic stir to get that mixing up. And then I'm going to use some phenolphthalein as a pH indicator. This is just going to tell me when I neutralize any acids that are in this oil. Now, I have no idea what this titrate's at, so we'll all have fun together here. A tip though, if for some reason you run out of phenolphthalein because it's kind of hard to find, you can run down to the local drugstore and pick up turmeric powder. Turmeric spice actually can be used to titrate with. It's not as accurate, but in a pinch, it will get you by. It does a pretty good job. So I'm going to put a couple drops of this in. A lot of people ask, well, how many drops? It doesn't really matter. A really good analogy I use is if you're on a road and you're flying by and a cop is sitting there, you can have 1 cop or you can have 5 cops, and if they've all got radar guns out, you only need 1 to see what the speed is. This is acting like a radar gun. Either it'll indicate when that pH changes. So not many drops, 1, 5 drops, really doesn't matter, just some. So, come on in. Pass those wires back there. Okay, to do the titration, I've got 10 milliliters of titration solution that I put in my syringe, just because it's a nice, easy starting number. A little on top. Okay. Okay. Any guesses?
What's the guess range?
Yeah.
I have no idea what kind
Is
of.
there numbers to
Yeah.
to
Any
guess?
guesses how many mil? For those that have titrated, how many mils do you think this is going to take?
12.
12. Okay. Anyone else? Okay, before I start, I'm going to show you a trick. You smell the oil. This can actually tell you how good the oil is. You can move that if you want. Go ahead and pass that around and kind of try not to spill it because they'll kill us if we do. To me, that smells fairly good. That it has a smell of, I've just fried a couple things in it. Doesn't smell bad. If it smells nasty, like a dead rat, it's probably going to titrate in the 20s, and oil can get that bad. But this oil smells pretty nice. So, 6-ish? Okay. Anyone else? 9? Okay, let's find out.
What you get?
Huh?
What you get?
I'm going to guess 4. But we'll see. What we're looking for is a pink color, and if you can see this changing, it's changing pretty quick. And coming back. Hey Doris, has that got me?
Yeah.
Okay, cool. Oh, there we go. See it turn purple? Now it's coming back. I like to have it go purple and stay purple for about 20 seconds. There we go. One and a half. Pretty good, huh? Almost 2. Okay. Okay, so that's really good. So now let's talk about what you do with the titration. When you're titrating for small batches, you smell that?
Yep.
Cool. I like to titrate 3 times and take the average. We're kind of low on time, so we're just going to do this today. But this titrated at 2. In other words, it took 2 milliliters of my titration solution to turn this pink color. And I really want it to stay pink, which it's done. If it starts turning back, you need to keep adding more. Okay, I'm using potassium hydroxide, which is KOH. In biodiesel, we know that if I was using absolutely pure potassium hydroxide, I would use 7 grams for every liter of oil that I was going to make. Okay, this is assuming a titration of 0. My KOH isn't pure, it's a little less pure, and so I'm going to divide it by the purity. This is about 90% pure, so someone with a calculator, I believe that gives me about 7.6. Someone whip out a calculator and let me know.
What are the numbers?
Take 7 and divide it by 0.90.
7.77.
Okay, 7.8, we'll round up. Okay, so that's my base. If this had titrated at 0, I got call it 1.75. So I'm going to do the math real quick and add that together for me.
9.55.
9.55. Okay, I like to always round up because if you add a little bit more, I'm just kicking the reaction a little bit more and I'm getting a good one. So I'm going to call this 10. So for this oil, for a liter, I'm going to use 10 grams of KOH. Okay, let's talk about the recipe for biodiesel. On this sheet, on the very first one, I talk about what you're needing. We're going to start off with a liter of oil that I've got warming up over here. Okay. We'll put it in this bottle. I've got 200 milliliters of methanol. So here's the basic recipe. For every 1 liter of oil, you'll use 20% methanol. So 1,000 liters, going to give you 200 milliliters of methanol. For catalyst, for every liter, I'm going to use 10 grams. Okay, I'm going to mix these two together put it in my bottle, shake it, hope for the best. So should we make some biodiesel?
Before you do that,
Yes.
you have, if you said if the oil was pure, it runs 7 grams per liter,
Uh-huh.
right? Underneath that, what is it you have written under 7?
By purity of my chemical.
Right.
So this chemical is only 90% pure.
Oh, okay.
And so to counter that, I
In other words,
divide.
that's 90% KOH.
Yes. And when you buy KOH and it says 100% KOH on the side, it's not the purity. You got to ask the chemical provider what the purity of the chemical is. Sodium hydroxide is typically 95 to 98%. Potassium hydroxide is about 90 to 93% when you buy it.
Do they usually put that on the label?
Huh?
Do they usually put that on the label?
Some do, some don't. So it's really important to ask.
All
If
right,
it's
and then going back to the 1.75,
uh-huh.
that was from where now?
I took 7. This is what I titrated at. In other words, it took 1.75 milliliters of my titration solution.
Oh, I thought you called that 2. Okay.
Took about 2, but the thing was almost 2. So, other questions about the recipe or the numbers for quick? Okay.
Okay.
Yep.
Well, sometimes you might use a little over 20% methanol, depending on oil, like 22%.
You can. Yep. In the industry, a lot of people can do 20% or 22%. On a commercial, now I'm doing just basic homebrew recipes. On a commercial scale, it changes a little bit because you're using sometimes sodium methylate or you're using a little bit pure chemicals, and your equipment's a little bit better than a home brewer. But in general, with a home brewer, we use 20 to 22% methanol. I've always just used 20. And then you've got the titration figures in front of you. So, other questions? Okay.
So the 1.75 was grams per liter of titration.
1.75, in other words, it took 1.75 milliliters of titration solution to turn this pink.
And your units don't match then. You got 7 grams per liter, 7.8 grams per liter,
I added
1.75 liters. I mean,
No,
milliliters.
1.75 grams. That gives me 9.55.
So that was grams per liter, then,
Uh-huh.
1.75.
Yep.
Okay.
I rounded it up to 10. So to make
Right on.
biodiesel out of this, I'm going to use 10 grams of potassium hydroxide, which is with 1 liter of oil and 200 milliliters of methanol.
Okay.
So this is 200 milliliters here. We'll weigh out our grams here. When you're titrating, the titration solution is so not dangerous that I could actually drink it. I don't recommend it, but one day we used to always worry about wearing glasses and goggles and stuff when you titrate. This is less basic than soap. I could drink it and it wouldn't hurt you. It's not a bad idea to wear gloves, but when you do handle the actual chemicals is when you want to break out these.
Graydon,
Mm-hmm.
would you say that most home brewers do these steps or no?
Titrate?
Yeah,
They should be, yeah.
like even with the BioPro and everything?
With a BioPro, it makes some assumptions about your oil, and that assumption is that it titrates no higher than 9.
Okay.
And so if you know, they should be titrating at least once every now and then if you're getting the same oil. But if they don't, the assumption is that it titrates no higher than 9. They put the catalyst and stuff in it, and they hope it works. Doesn't always work. I titrate every single batch, even in my BioPro. Okay. Let's have fun. Titration stuff out of here. Other questions before we roll along here? So I'm going to measure out 10 grams of potassium hydroxide. This is just a generic scale. Often I get questions about how accurate you need to be when you put it in. As long as you're within, say, 0.5 of a gram, you're okay, and if you want, you can round up. You don't want to be under. So I'm at about 10.2. It's good enough. Okay, and it goes. And then you wait for it to dissolve. So I'll swirl this around for a little bit while we talk about a couple other things here. Using either sodium hydroxide or potassium hydroxide, there's some benefits to both chemicals. For potassium hydroxide, the biggest benefit is that it dissolves much, much quicker than sodium hydroxide does. Sodium hydroxide, say in a 5-gallon carboy, can take up to an hour to dissolve. In potassium hydroxide, it's usually dissolved in under 20 minutes and you're done. This will be dissolved pretty quick. See it bubbling? When this happens too, you're making what's called an exothermic reaction. So it does generate a little bit of heat. But let's let this sit there. Okay. Let's come back a little bit to how biodiesel is made. So you're going to go out and you're going to get your oil. You're going to come back home. You're going to titrate it, figure out what it's going to take to make the fuel, and you get your recipe aside. We'll make that batch here in a second. But I wanted to talk about the other steps to making biodiesel because they don't get talked about a whole lot. So when you make biodiesel, this is the basic reaction. You're going to get biodiesel on top. You're going to get glycerin on the bottom. And that glycerin you'll drain off. Now you're left with a product that has biodiesel, and like I said back here, has a little bit of soap in it as well, and it's got a little bit of water in there, so it's crude biodiesel. It's not fully ready to use. And so your next step is to wash that biodiesel, or to remove the impurities of it. There's several ways you can do that. One of the most common ways with a home brewer is to simply use water. And so you would get a drum, you'd get a tank, what have you, and you'd have a sprayer on top of that, and you'd spray water on it, and the water will remove those impurities. It'll pull out excess methanol, it pulls out excess soap, pulls out pretty much anything that's left. It'll even pull out a little bit of glycerin. If you notice, the water on the bottom of this is cloudy, and that means that I'm still not done washing it. So as you wash the fuel, you wash it, let it settle, and typical times, I'll wash it for about 2 hours with the mister on. I'll let it settle for 2 hours, I come back and I drain the water off. And I repeat that until the water starts coming out clear. And when this water is clear, then I'll pull a sample of the fuel. I'll pull a well-mixed sample, I should say. You don't want to just pull right off the top, because if there's soap and stuff in it, a lot of times it's sitting on the bottom. So I'll either mix up the sample or I'll pull right from the bottom. And I'll do what's called a shake-em-up test. I'll fill a mason jar halfway full of biodiesel and halfway full of distilled water. If you can't get distilled, you can use tap water, but we like to use distilled if you can. And I shake it like a margarita. You just shake it really, really hard. I'm going to shake this one. By the way, that's what an emulsion looks like, for those of you that haven't made one yet. And the trick to breaking them is salt water, and lots of it. We've got an article on that. But if the water settles out after about an hour, crystal clear, there's a really high likelihood that you've gotten rid of the majority of the soap, and you're now within levels of ASTM. At that point, you take a sample and you perform a soap test. We won't talk about that today, but on our website we've got tutorials on how to do that, and I think Sam Parker might be doing that a little bit later today as well. Okay, once you get the water, or once you get the fuel all the way washed, and you get it to the point where you think it's done, then you have to dry the fuel. This is biodiesel that's wet. Notice it's cloudy still. Okay? So to dry it, you can either aerate it, you can bubble it, you can put it out in the sun and let it heat up and dry off. One of the most common ways that I like to do is simply by heating, circulating, and spraying it. I'll spray it through a nozzle that sprays it in a nice fan-like pattern into an open-top container, and that container's been heated so the oil's nice and warm, And what that does is it allows air from the bottom and the top to grab a hold of the moisture and get rid of it. Temperatures that I like to use are up to about 100 degrees or 120 degrees Fahrenheit. I don't go much higher than that. You're just, in my opinion, kind of wasting energy with the higher you go, because lower temperatures will still accomplish the same thing. How dry do you want it? This is clean, washed, dried biodiesel. See how clear that is? It's cool in this room. This hasn't been heated at all. You want it to turn out crystal clear like this. What I do is I'll pull a sample of it and I'll perform a water test on it. There's two ways to do that. There's several, but the most common for home brewers is you get a frying pan out and you take no more than about, half of this vial, and heat up your frying pan like you're going to cook an egg in it, and take some of the biodiesel and just pour it in. You want to do this in an open area because if it's wet, it's going to spit, just like if you were frying chicken in a deep fryer. You don't want to see any bubbles. You don't want to see any steam, any hissing. You want to see nothing but oil just getting thin on the bottom of the pan. When it's that point, there's high likelihood that you're dry. At that point, if you need to be super accurate, you can take a more accurate reading using a Carl Fisher test, or we sell something called a Sandy Bray water tester, and you can measure what your parts per million are. The ASTM standard for biodiesel for dryness says it can't have more than 500 parts per million of moisture content in it. Once you're to that point, find your truck and fill up. You're ready to go. Okay. I'm waiting for this oil to cool down. We got a little bit hot there. So, another test that we do, and I'll show you, is after I have made it into biodiesel, but before I start to wash it, I will check to make sure that I got all of the triglycerides reacted into biodiesel. And I do that through a test called the 327 test. How many of you heard of that test? So a fair number. So we're going to actually do one right here. This is biodiesel from here. I've not tested this, so it'll be interesting to see what it turns out. I take 3 milliliters of biodiesel, I put it in a vial. To it, I add 27 milliliters of methanol. These vials are handy because they've got a 30 milliliter mark on the side, so you put 3 mils and then you fill it the rest of the way full to 30. You want this to be as accurate as you can. Also, the biodiesel and the methanol both should be no hotter than 72 degrees Fahrenheit for this test to be accurate. If they are, there's a chance that the methanol will dissolve biodiesel that is still unreacted. There's a lower temperature as well, and that's about 68 degrees Fahrenheit. So you want your biodiesel and your methanol to be between 68 and 72. Okay, I've just put that in. I'm going to let that sit for a minute. What you're looking for is you want it to completely dissolve. You want nothing left in this at all. If you have any fallout that falls to the bottom, that's indicating that your reaction didn't go to completion and you still have some fatty acids that haven't been broken off and made into biodiesel. For the technical people in the crowd, this test is really good at detecting triglycerides and diglycerides. It's not the greatest at detecting monoglycerides. But if you pass this test and you've done it right, we found correlating it to the ASTM test for total glycerin that you will have a high likelihood of passing your total glycerin test under the ASTM standard. This is already doing, I'm getting a little bit of fallout there. It's puddling on the bottom down here, and so what that tells me is this batch, it's not even been 5 minutes and I'm getting something coming out. That's how quick I can read this test. This didn't go to completion. Something about this batch didn't happen right. Let's talk about those things that might cause a batch to do that. The number one thing I see that people have run into is water in the oil. So before you even start making biodiesel, typically before you even titrate it, check the water content on your oil. Because if there's water in it, it's going to make soap and it's going to get in the way of making a good batch of biodiesel. If you get your oil good and dry, that solves about 90% of the problems of making biodiesel. Okay. Other things that can cause this to go bad: not adding enough catalyst. I didn't heat it hot enough. My catalyst has the lid open. I'm getting chunks in there. A note about chunks in catalyst. A lot of people sometimes have had catalyst that's been left open and there's not chunks in it, but it's been sitting around for a while and they still wonder why they're not able to make a good batch. There's two ways that catalyst goes bad. One is by it sucking in moisture, and that's where the clumps come from. But two, it also, the moment I take this lid off, it starts carbonating with CO2 in the air, and it'll go bad that way. I've seen sodium hydroxide look absolutely brand new in look, but be absolutely toast. My rule of thumb is if you've had a bag of catalyst and you've cracked the seal on it, and it looks good, no more than a year. After a year, just get rid of it. It's not worth having around because it causes problems. So, questions? Yes?
You mentioned water in your feed oil.
Mm-hmm.
Are things like the water rejecting filters used in, say, diesel trucks, are they good enough to get that level of water out of the oil?
You'll plug them real quick. They'll pull it out, but they'll plug
If you
fast.
pre-filter and then run it through?
If you pre-filter it through one of those filters and it doesn't plug up, that's a good chance you got it out, but I still would do a fry pan test, at least some sort of a test to make sure it gets
With
it
the
out.
raw oil?
Yeah. Let me give you some examples. If I had 100 gallons of oil, and let's say it's 1% water content, that's a gallon of water. Your little filter doesn't hold a gallon of water, the ones on diesel trucks. And so if you're 0.5%, that's still half a gallon. Those
You said that could be as much as a gallon of water per gallon.
if your oil has 1% water content
1% water.
and you've got 100 gallons, that's 1 gallon of water you're trying to get out of that oil. Let's say you're 0.5%, which is kind of typical. That's a half a gallon of water. Most fuel filters hold, I don't know, 20 ounces, which isn't much. And so if it's wet and you know it's wet, using those filters, you're going to eat through them real quick. A better way is to either let it settle or to do the heat and circulate method until you think it's dry.
So what's your water, sorry.
Brandon?
Besides the flash column, which gets pretty expensive to put on your front end, I mean, what temperatures do you need when you heat and circulate it to try to reduce?
No more than 100. I don't really go much more than 100. Even 80 will do it. The lower the temperature, the longer it's going to take. The higher the temperature, the quicker it's going to take. But there's kind of a diminishing return once you get past a certain level. Water boils at 212 at sea level. Here it boils, I don't know, a lot less.
97.
Huh?
97.
Centigrade?
Yes.
Okay. So a lot less. Yes.
So what's your water parameter for a base reaction? What do you want to be less
That's a
than?
great question. I don't like to see my water content any higher than about 0.25. That's 2,500 parts per million. If my oil titrates over 5, I don't want to see it any higher than 1,500 parts per million, or 0.15. Because you're going to start producing some water when you make soap if you do have a high titration oil. So, good question. Others? Okay, let's take a look at our test. The test fails if you get any fallout at all. I'm going to pass this around. I've got probably about 1/4 of an inch of fallout. This batch didn't go well. Something plainly went wrong. I'll pass this around so you can see it. I tilted it on that angle. Can you burn it? Yeah. Should you burn it? Depends. If you're selling it, should you sell it?
No.
No. Because you are so far out of spec if you flunk this test. Most indirect injected engines, though, can burn this fuel because they can burn vegetable oil. However, if your goal is to make high quality, well-reacted biodiesel, you want to pass that test. Okay, let's make some biodiesel.
So what do you do with a batch that fails the test?
If you fail a bit test, the cool thing is biodiesel, you just re-react it. You just add a little bit more catalyst and a little bit more methanol. I typically do about a 20% to 30% of my catalyst and methanol. So if I used 10 gallons of methanol, that's 2 gallons to re-react it, or 3 gallons if you're doing a 20 or 30%.
Do you look at the residual alcohol in the 320, I think the residual oil in the 327 tests,
Mm-hmm.
and say, well, that looks like 25% or 10% of what I did, so that's how much is unreacted.
I kind of have a rule of thumb.
Titration.
My rule of thumb is if I have more than 1/8 of an inch, I'm going to do 30% re-react. If I have less than 1/8 of an inch of fallout, I do 20%. So. Okay, temperature on this oil for the mini batch. I really don't like to go much higher than about 120. I'm in a small bottle, I'm going to shake it. It doesn't really need to be much hotter than that. I hit 160 when I walked in the room though, so that's why we let it cool down a bit. Okay, so I've got a liter of oil. We've got this all dissolved. Let's mix it up again, just make sure. Pour that in. You'll notice this goes right to a caramel color almost when it gets in there. Okay. And then you just shake it. Notice that caramel color? This is going to change color as we mix it. Anyone want to come up and shake it? Shake?
I don't know. Yeah.
Oh. Go ahead. Take a shake on that and pass it around here. We'll shake it.
How's it hot?
It's hot because I've started with hot oil, but it's also getting a little bit hotter because I'm having an exothermic reaction that's going on. When you mix, look at that color. We've already changed color again. So we've gone from that caramel looking color to kind of a darker color, and it changes color as we go. Okay?
Any concern about pressure when you do a 2-liter demonstration?
No, that cap's on really, really tight.
Okay, then.
I've never
I've
seen
certainly
it.
never built a 2-liter bomb, so.
Doing a 2-liter CO2 bomb generates a lot more pressure. There's not a lot of pressure in there that's been generated. Yes?
Have a small amount of pressure in your tank help the reaction so you don't lose your methanol from the heat.
That's a really good question. I'm going to defer a little bit of that to Rudy a little bit later. But in commercial settings, a lot of plants like to use pressure because that causes you to have to, you can use lower temperatures when you react. Is that right?
Well, the pressure keeps the methanol from escaping. The closer you are to the boiling point of the methanol, the faster the reaction. So you trade off temperature with time.
For homebrew, we typically don't put biodiesel under pressure when we make it. We leave the vent open. There was a lot of discussion over the years. You can leave it open, leave it shut. It's not going to generate a lot of pressure, even in a water heater style or a poly tank. A little note about processors, though, while we're passing this around. If you process in a plastic tank, do not exceed the pressure limits of that tank. Did you blow the pressure off?
Yeah, a little bit's gone.
Pass that along. You want to let it spit, huh? Do not exceed the limits on your tanks. Most LDPE tanks can't handle anything more than about 120, 130. MDPE, which is medium density polyethylene, is about 140 to 160. HDPE is about 160 to 180, but it kind of depends. So if you've got a tank that is a standard cheapo farm tank, it's probably an LDPE tank, and you heat that oil up to 160 and you put it in there, you're going to melt a hole right in the side, and now you've filled your shop with oil. So be cautious if you're using plastic tanks. I like to use plastic tanks for washing. I'm not a fan of using plastic tanks for processing. How are we looking?
Good.
Over there somewhere? Awesome. Okay. So we've made our mini batch of biodiesel. Looking good. Okay. I don't have a whole lot of pressure. Let's see. Huh? Yeah, you vented it all? There's not a lot there. You shake it for about 10 minutes when you make a mini batch like this. We don't have the time to let it settle out, but I usually let it settle for about 2 hours. Since we're in a demonstration, you want to be the cook in the kitchen. This is what it's going to look like when it settles out. You're going to get, it'll be a little bit thinner than this one because this is such a small batch. A tip for draining off the glycerin, you can either put this whole batch in another container like a separatory funnel and drain it off, or if you're real careful, you turn this on its side, use your thumb and very gently drain it off with a glove on because it's still got methanol in it. The easiest method though is to pour it into some other container and then drain the glycerin off that way. You can actually wash in this container as well. So, okay, let's talk a little bit about some of the tests we do. This is a little bit better picture of the different stages of biodiesel that we've done. So we've talked about all these different stages where we start with the oil seeds. Where's my oil seeds at, by the way? The soybeans?
Right here.
They're good? So biodiesel can be made from several things, but the most common in the United States, if any of you were here last night, is commercial biodiesel is mainly made from soybean oil. And that's just a fact that we just plant more soybeans than anyone else in the world. So, but you can make it out of any kind of organic oil or fats. Any type of a thing that forms a triglyceride that can be made into biodiesel. Fats are a little bit harder, aren't they, Rex? Okay. So we talked about a little bit testing for water, how important it is. We walked through a titration. Questions about a titration? How many of you titrate with phenol red? How many? Okay. That's the other chemical you can use. How many of you do phenolphthalein? That's what this one is, and it turns this pink color. Phenol red turns a darker red. Phenol, actually we've got some turmeric. We've got some, let's see if we got a spare one. Got a little bit of time.
Will red cabbage work?
Huh?
Will red cabbage work?
I've heard that it will, but I've never done it. So it might, I don't know. We'll do one with turmeric here. Okay, it's 1 milliliter of oil. 10 ml of alcohol. Titration solution. Okay, I'm going to use a little bit of this turmeric because it's really cool when you use it. It turns this, and you don't have to use very much at all. It turns this yellow color when you start using it. See that yellow? And then it turns the coolest color when it turns. So we'll start that. Okay. This is how I usually titrate. So you just swirl it around, put some drops in. See that color change? It turns a blood red. It's the coolest thing in the world when it does it. I found that when you use turmeric, though, you got to mix it a little bit more than when you're using phenolphthalein. Ooh, yeah, look at that. When it changes color and changes back, what it's doing is the acids are neutralizing your base that you've put in there back, and so I still have more acids than I have base. When this turns completely to that color, it means that I've used all of my base to completely neutralize all of my acids, and now I'm taking it into the base range of the pH scale. Getting there.
So numerically, your pH is increasing as you continue to add.
Correct.
You were acidic.
0 to 7 is acidic, 7 to 14 is basic.
And where does this one turn?
I'd have to go look it up. I think it turns at about 4. It tends to turn a little bit sooner if I remember right. Okay, see that blood color? Okay, so it's starting to come back again. I'm right at 1.25, so it turned a little bit sooner than my phenolphthalein did. If you round up, you should be okay though. So I want to get a really deep red here. There we go. Deep red. I like to call that blood red. I'll pass that around. So. Yes?
Would you mind showing us an example of equipment for each step, like what people use as when they turn up?
Sure. Bet. Let's go into here.
The initial processor you have there for warming the oil, I assume people just use 55-gallon drums?
Sure, you bet. So, actually, let's go to the equipment section. First of all, first thing that you're going to need when you make biodiesel, again, this is just kind of mini batches, but you need to filter the oil. When you filter the oil, I filter it no more than about 400 micron for biodiesel. A lot of people take it smaller than that. You can if you want. I've never found a real benefit, at least to me, and so I don't go any lower than 400. You can use bucket filters, drum filters, centrifuges. Love if you've bought centrifuges and use them. We sell them. They're wonderful. And get it down to about 400 microns. Once you do that, then you need to dewater it if you've got any water in the oil. I'll show you an example of a dewatering tank. So I took a 55-gallon drum. This is nothing special. You take a 55-gallon drum, I put a band heater on it, I hooked a cheapo pump up to it, I came up to the top and I'm spraying in the top through a nozzle. The nozzle's kind of special. It's called a dry pro nozzle that we carry, but other than that, I'm just heating, circulating, and spraying that oil till I get it dry. Okay? So for processing equipment, let's find a processor. You can use pretty much anything that you can heat and stir in, and that can include 55-gallon drums. Actually, I'll show you one of the very first processors I ever made biodiesel in. Doesn't that look dangerous? That was the first processor we ever did it in. It's a 55-gallon drum. Who can spot all the hazard things there? That's a sleeping bag. That's a drill. Yes, that's a drill. Yeah. I have methanol fumes in a closed shed. What happens when you put methanol fumes in a closed shed? You can go boom. Yep, but that was back in the day when we really didn't know any better, and let's see if I get a better shot of that. We survived. We did. We made pretty good biodiesel. We didn't have tests to figure out how well it went. Okay, cool. To wash the biodiesel, you can use the same type of a drum. You can use a poly drum and spray it from the top. Lots of wash tank. It looks like I got about a minute left. Come up and talk to me afterwards. I can talk to you a little bit about that. So processing it, you just need a heating tank that you can heat and stir. If you've done waste vegetable oil for years and you had something that heated it and get stuff dry, it'll work. You just need to heat it and circulate it. Washing it, we talked about spraying water. You just need a container you can spray water into and stuff that comes out the bottom. I really like poly tanks for washing because it's nice. You can see the differentiation between the water and the biodiesel, and you drain it off till you hit biodiesel. If you want to go high tech, the BioPros absolutely rock. You put oil, chemicals in, you push a button, and you walk away. You come back 24 hours later, you drain off the glycerin, push another button, it starts a wash cycle, come back another 24 hours later, it's washed it 3 times, it's dried it, and now you're clean, ready to use biodiesel that looks like that. So, questions? Yes?
If salt water is the trick to break emulsions, why do you not wash with salt water?
Initially?
Yeah,
Because you don't need it.
you just have to wait a long time for the water to separate.
Even if you use salt water, you've still got to wait for that separation. Salt water is just, the other thing is you don't want the salt water in the biodiesel because then you have to go back and wash it out. Even if you break the emulsion with salt water, I have to come behind it with a couple more washes to get it out.
I got you.
So if you want to prevent emulsions though, you can use vinegar. So just a plug for a DVD we carry. If you'd like to learn just about everything we've done here 10 times more, I sell a DVD. It's 6 hours of education. It's like sitting in a college course, and they walk through everything. All these tests here, he goes into more depth. They make a batch of biodiesel. It's a good friend of mine named Lyle Redenzi in Seattle. If you've ever had a chance to meet him, you understand why we like it so much. It's just great, great DVD. Also, if you have any questions about making biodiesel, give us a call. We're Utah Biodiesel Supply. Our phone number is right on the website. Let's see if I can grab that. You can call, email. We have a Facebook page we respond to all the time, but we're happy to help you. So, other questions? Okay, thanks for coming and watching.